Welcome students. In today's class, we will discuss what is meant by system, what is meant by system, and also we will discuss different types of systems. So these are the topics of discussions. So what is meant by system? So system is a physical interconnection of devices. System is a physical interconnection. It's a physical interconnection of devices of various devices. Okay, so this black box we call as a system, and this system has input and output. So if you observe, this system has some input, let's say xt, and it has output, let's say yt. This system is called as single input, single output system. Since it has single input at the input side and single output at the output side, it is called as SISO type of systems. But there are types of systems in which there are multiple inputs like this, okay, and there are multiple outputs like this. Such systems are called as MIMO type of systems, which are nothing but multiple input, multiple output. But these are the broad classifications of systems. We denote this system by a black box. This is a broad classification of system. In general, there are various different classifications of systems. We'll discuss it later on. But to begin, what exactly mean by a system is? System is a physical interconnection of various devices which perform certain operations, on input signal, which perform certain operations on input signals and give desired results, okay, so this is the main use of systems. Systems perform certain operations, mathematical operations, logical operations on the signals and gives you a desired output. Okay, so this is what the main purpose of the system. uh, 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 it it works mainly with, or it deals mainly with various signals and extracts the required features out of it. That's why the desired word is very important. The output, many a times in system terminology, is called as the response. The output many a times is called as a response, and the inputs are called as excitations. Inputs are called as excitations and outputs are called as a response. So these are the terminologies which we have to remember uh, for further studies. Now let us move ahead. There are different types of systems that we use in our day-to-day life. So let us discuss types of systems. What are the different types of systems? So first, very important system is a linear non-linear system. Linear non-linear system. The second type is a causal non-causal system. Causal systems or non-causal systems. The third category of the system is time varying, or time invariant system. So this is the third category of the system. Fourth system is a static or dynamic system. Static or dynamic system. These systems are also called as memoryless system, memory or memoryless system. Okay, this is another name for this system. The fifth category of the system is stable unstable systems. Stable systems, unstable systems. This is the fifth category of the system. And the sixth one is a very important, inverting non-inverting systems. inverting, non-inverting systems. So in detail, we'll discuss all these systems in details, how systems can be tested, whether it is a linear, non-linear, whether it is a causal, non-causal, whether it is a time varying invariant, whether it is static dynamic, whether it is stable, and how to check such systems, that we'll discuss in detail. Okay. So before that, let us begin our discussion with um, time with linear, non-linear type of system. Okay. So let me create a new tab. So we'll start our discussion with linear, non-linear systems. So how to test whether the given system is linear or non-linear? So there are few tests. There are few tests, or there are few conditions which we need to carry out while testing whether the provided system, whether the given system is a linear or non-linear. So what are those tests? So first test is called as law of law of additivity. Law of additivity. And the second test or second condition is called as law of homogeneity. Law of homogeneity. So if system obeys these two conditions, if system follows these two tests, okay, then only the system is said to be linear. Then the system is said to be linear. If system fails or violates any one of these two tests, then the system is non-linear. Okay, so it should obey the law of additivity as well as it should obey the law of homogeneity. These two laws in together is called as law of superposition. We have studied this in networks and systems. This is called as law of superposition. So any system in general, if it obeys the law of superposition, then the system is called as a linear system. All right. So what is law of additivity? What is law of additivity? And what is law of homogeneity? Let us discuss in a while. Okay. So what is law of additivity? Suppose if we apply a system, if we apply input x1 to the system, okay, and it produces, let's say, output y1 of t, okay, then suppose if input is applied with, let's say, different input x2t, and the same system we are having under consideration, and if it produces output y2 of t, then the law of additivity says that if we add these two inputs at the input side, then the output shall also get add. So y1t plus y2t. Okay. So this is in general a law of additivity. And the same ground, on the same ground, uh, we can say that if input is scaled by some factor, if input is scaled by some factor, then output shall also be scaled by the same factor. Okay. So this is what law of additivity. Along with this, I have also explained the law of homogeneity also. What is law of homogeneity? The scale factor is nothing but law of homogeneity. That means if any input, if input x1t is scaled by some factor, then the output, then this system produces output of same time, that is alpha times y1t. So this is law of homogeneity. This is law of homogeneity. And therefore, if system follows these two conditions, then we can say that the system is linear. Okay. So first of all, we need to understand what is exactly law of additivity. So law of additivity is nothing but simply if we apply input x1t, it produces output y of t, y1 of t. If input applied is x2 of t, output produced is y2 of t. If we add these two inputs, the output shall be the addition of the outputs generated in the previous states. Okay. Similarly, the law of homogeneity states that if input is scaled by some factor, let's say here x1t is scaled by alpha and x2t is scaled by beta, then the output shall also be produced. Output shall also be scaled by the same factor, that is alpha and beta. This is called as law of homogeneity. And in general, if this system obeys these two different laws, then we can say that the system is linear. To test, let us take example. So first example, let us take first example. Y of t is equal to x t square. Okay, and we want to test whether the given system is linear or non-linear. So we have to test whether the provided system is a linear or non-linear. So how we can do that? So for that, the first uh, law that we need to apply, or first test that we need to carry out, is nothing but let me change the color, is to use law of additivity. Okay, so suppose x1t is the applied input to the system. Okay, and it produces output y1 of t, which is equal to x1 t cube. Okay, similarly, let's say input applied is x2t. If it is applied to the same system, it produces output y2t, which is nothing but x2t cube. All right. So if I add outputs y1t, which is y1t plus y2t, then this new output, let me call it as y dash t, which is x1 t cube plus x2 t cube. So let's mark this equation as equation number 1. Suppose in the next case, if we apply input x1t and x2t in combination. So this is first step, this is second step. In second step, we are applying input in combination to the system, previous system, and it produces, let's say, output y double dash t. So y double dash t will be equal to, here instead of x, here I am substituting x1t and x2t. So my output shall be x1t square plus x2t square. I'm sorry, I made here cube, this should be square. Let me correct it. So if you observe, this y dash t is equal to y double dash t, and therefore it obeys law of additivity. It obeys law of additivity. Let's test law of homogeneity. So let's test law of homogeneity for the given system. So our system is y of t is equal to x t square. This was the system. So if input xt is equal to 0, let's say, this is very simple test to test law of homogeneity. If input is 0, then if it produces output is equal to 0, then the system is homogeneity. That means if I scale input by 0, then output shall also be resulted into 0. So therefore my system obeys, it obeys both rules, it obeys both rules, and therefore both rules means law of additivity as well as law of homogeneity, and hence the conclusion part is the system is linear. The system is linear. So this is my answer. System is linear. Right? So let us take few more examples to understand things more clearly. Alright. So let's take y of t is equal to, let's say, x square t. This is my system. So first, law of additivity. So law of additivity, it states that if input x1t is applied to the system, which produces output y1t, which is equal to x square t. Alright. And if input x2t is applied the same system, it produces output y2t, which is equal to x square t. I'm sorry, this is x1 and this is x2. Now, if I add y1t plus y2t, which produces the output y dash t, which is equal to x1 square t plus x2 square t. Let's mark this as equation number 1. Now, suppose if I apply, this is my step number 1. Now in step number 2, if I apply input, so second step is apply input in combination. Apply input in combination. If I apply input in combination, let's say x1t plus x2t, this is the input applied to the system. Okay, same system I am discussing about. It produces output y double dash t, which is x1t plus x2t whole square. Okay, so this is what it is. So it produces output as x1 square t plus x2 square t plus 2 times x1t into x2t. And you observe in this case your this output y double dash t is not equal to y dash t. Therefore, the first law, that is law of additivity, is violated. And therefore, if system disobeys any one of the two rules, then the system is nonlinear, and therefore there is no need to test the second law, that is law of homogeneity, because system disobeys first law itself. Therefore, we can conclude that the system is non-linear. Right? Let us take one more example. Suppose y of t is equal to sine t into xt. Right? So here, if input x1t, then my output y1t, it produces output y1t, which is equal to sine t into x1t. If input is x2t applied to the system, it implies it produces output y2t, which is equal to sine t into x2t. If I add these two outputs, that is my new output y dash t, which is addition of y1t plus y2t, which is equal to sine t sine t x1t plus sine t x2t. If I take sine outside, then this will be sine t inside bracket x1t plus x2t. So this is my output y dash t. Now let us check output y double dash t. If I apply input x1t plus x2t in combination, it produces output y double dash t. So this gives rise to sine t inside bracket x is replaced by x1t plus x2t. And if you observe this equation number 2, and this equation number 1, in both the equation, that is y dash t and y double dash t, both are same. Therefore, it obeys law of homogeneity. And similarly, as I explained in the previous case, if you test here, if input x of t is 0, in this case, if I write here input x of t is 0, then my output is also 0, and therefore system obeys both the rules, and hence we can conclude that the system is linear. So here we can conclude our discussion that this system is a linear system. So this system is a linear system because it obeys both law of homogeneity and law of additivity. So both laws are obeyed, and therefore the system is linear. So I think this is all about. Thank you.